Hello everyone, welcome to David Griffiths Electrodynamics, problem 2.18. Alright, so we're finally finishing up this section on some simple electrostatics problems and Gauss's law problems, basically, a lot of Gauss's law practice. So, we have two spheres, each of radius big R. They carry a uniform charge density of plus rho and minus rho respectively, and I've marked that here on the diagram. So this one has plus rho and this is minus rho. They are placed so that they partially overlap, which you can kind of see here. So just sort of imagine these two, there's two spherical objects and somehow they overlap, I guess. And call the vector from the positive center to the negative center D. Show that the field in the region of overlap, so the electric field here in this region, is constant, and find its value. And it gives us a hint to use our answer from problem 2.12, where we were asked to find the electric field inside of a uniformly charged solid sphere. So from 2.12, if you haven't solved it already, or if you have already, I have the answer readily available. So from 2.12, the electric field inside of a uniformly solid sphere at some arbitrary point is rho over 3 epsilon naught, I believe, and the r hat direction. And where r hat is the vector to the point in question, from the center to the point in question. So let's consider a point here in the region of overlap. Well, this sphere, it's inside of this sphere, and so it produces a vector, electric field vector, this way, away from it, considering there's a point charge here. And then consider we have, in this sphere, produces a vector this way. So it would be in this direction towards it if it was a positive point charge, because it should attract it. So we'll call this vector r plus and this vector r minus. And well, let's just look at this diagram here. So r plus r minus would be our vector D, right? And so let me just first say that the electric field produced at some point here from this sphere is rho over 3 epsilon naught r plus, and from this sphere it's minus rho over 3 or epsilon naught in the r minus direction. And so if we add these two vectors together, then we get, let's see, so I'll call this E plus, E minus. So E plus E minus would give us, we can factor out rho over 3 epsilon naught. We get R plus minus r minus. I guess I'll put the vector symbols over that. And this is just the vector D. So so we've shown basically that the electric field in this region here is just rho over 3 epsilon naught vector D. So given a that's basically it. That's pretty much all there is to show. We've shown that the charge experiences a constant electric field, so the magnitude here is constant, and yeah, that's its value. So that's it. It's a pretty simple problem. It's more of a conceptual problem. The hardest part was just, well, I guess it gives you the hint for using the answer from from 2.12. That's pretty much all you really need to just kind of reason out this answer. Just more of a reasoning problem, I guess. So I hope this makes it clear. This diagram makes it clear. And yeah, thank you guys for watching, and I will see you guys on problem 2.19.